Alright, dear children, now we will move to the next numerical problem, that is problem number 3. And this is also a problem based on first law of thermodynamics. Basically, from the chapter that we are dealing it, we focused basically on first law of thermodynamics. But there is second law of thermodynamics also, and that you learn in one of the chapter, the last chapter under unit number 8. Problem number 3 says that at 0 degrees Celsius, so what is the temperature? 0 degrees Celsius, and normal atmospheric pressure, that is also called NTP. The volume of one gas, 1 gram of water, the volume of what? 1 gram of water increases from 1 centimeter cube to 1.091 centimeter cube on freezing. Now, when water freezes into ice at 0 degrees Celsius, which is a constant temperature, then the volume of water increases from what? 1 centimeter cube to 1.091 centimeter cube. 1.091 centimeter cube, and this is on freezing. So in this case, there is some amount of heat that is taken out by the water, the heat which is taken out by the water, and water outed as a what system. The question say that what will be the change in the what energy? Internal energy. So what will be the change in what energy? Internal energy. So we need to calculate the change in internal energy. But before we calculate the change in internal energy, so we should calculate how much amount of heat that is taken out by the water to convert from water into ice. But this is the process called freezing. So for freezing, the temperature remain constant. For freezing, what will remain constant? Temperature remain constant. And when temperature remain constant means basically that process is called isothermal process. What process is called? Isothermal process. So at temperature 0 degrees Celsius, first of all we calculate the amount of heat that is rejected or withdrawn by the water. But under that case, what is given? The normal atmospheric pressure is given 1.013 into 5 Newton per meter square, and the latent heat of melting of ice. Latent heat also given. Latent heat of melting of ice is 80 calorie per gram. Means this unit of latent heat is in a CGS unit. So let me just do it. L is how much? This is for ice. This is for what? Ice. That is 80 calorie per gram. And what is the ice? Water. How much gram of water is converted into ice? That is 1 gram of water. So mass is M is what? 1 gram of water. So under this case, the water that withdraw or reject heat to convert into ice during freezing can be calculated by the formula, and the formula is Q equals to M into what? L. See children, you have learned this in class 10 also, in the chapter called calorimetry. So this is the heat, this is given out by 1 gram of water in freezing. So children, first of all, what we calculate now? The heat given out by 1 gram of water during freezing, and the formula is Q equals to M into L ice. Means L ice means latent heat of melting of ice. Freezing of what? Water, or that means melting point or melting of what? Ice. That is same. Because latent heat of melting of ice and latent heat of freezing of water is always what? Same, and that value is given 80 calorie per gram. But what is the mass? 1 gram. Now latent heat is how much? 80. So it will be how much? 80, and the unit is calorie only. So Q equals to 80 calorie. But children, as you know, that this is the heat that is given out by water. So if any system given out heat, if any system is given out heat, then that will be taken as negative. That means this heat is taken as what? Taken as negative. This heat is taken as what? Negative, which means I write on Q equals to minus 80 calories. So with sign I am writing. But children, you know that during freezing, the water expand is volume against the atmospheric pressure, and that volume which is expand, which is already given from 1 centimeter cube to 1.091 centimeter cube. So I write on during what? During freezing. During freezing, the water expand. Water expands in what? Volume against the what pressure? Atmospheric pressure. against the atmospheric pressure. So that's why there is a work done by the what? There is a work done, okay, by the water, and that work done I calculate. So I write down work done by the water, and that work done is given by W equals to P delta B. So children, pressure is against the pressure means at a constant pressure, the volume of the water is increases from 1 centimeter cube to how much? 1.091 centimeter cube. So definitely work is done by the water. So under this case, pressure which is given, and the value of pressure is how much? 1.013 to the 10 power 5 Newton per meter square, and the volume, change in volume means final volume is 1 point okay, 1 point how much? 091 minus 1 centimeter cube. But children, this unit which we are writing the value is in centimeter cube, but we need to calculate this work done in what? Joule. So to calculate the work done in joule, so 1 centimeter cube means equals to 10 to the power minus 6 meter cube. So children, after what I have done, I have converted 1 centimeter cube into meter cube, just multiplying with 10 to minus 6, because 1 centimeter cube is equivalent to 10 minus 6 meter cube. So this volume is to be calculated in what? Change in volume should be in what? Centimeter meter cube. That's why I multiply by 10 to minus 6. Okay. Now let's do the calculation of this, and the calculation is simply what? 1.013 into 10 power what? 5. Now this is 0.091 into 10 power minus 6, which means 1.013 into 0.091 into 10 power minus what? 1. Okay, which means 1.013 into 0.091 by, now 10 to the power minus 1, it will go in the denominator, that is 10. Now if you do multiply these two and divide by 10, you get approximately 0.0092, and the unit is what? Joule. So this is the work which is done by the water, and this work done which we have calculated is in what? Joule. So 0.0092 joule. But children, you know that your heat which is given out by water we have calculated in calorie, the CGS unit, and this work done we just calculate in joule. But we can write this work done from joule to what? Calorie, which means we can convert work done from joule to what? Calorie. So there is a relation, and you know the relation is 1 calorie is 4.18 joule. So if 1 calorie is 4.18 joule, then 1 joule equals to 1 by 4.18 calorie. So to convert joule into calorie, I multiply by 1 by 4.18. So I write down therefore W equals to 0.0092 into 1 by 4.18 calorie. Okay, so if you do the calculation or divide this quantity, so it will be how much? 0.0022 calorie, approximately 0.0022 what? Calorie. So this is the amount of what? Work which is done, and that work done we have calculated in what? Calorie. So 0.0022 calorie. Now this work is actually done, okay, by the water as a system is always taken as positive. This work done is positive. Because why this work done is positive? Because there is an increase in volume, the volume of expand. If volume expand or increase in volume, then that work done is taken as also as positive. But actually you have to find what? The change in what energy? Internal energy. Now to calculate the change in internal energy, we use first law of thermodynamics. And children, from first law of thermodynamics, we always write Q equals to delta U plus W. Okay, because delta U means what? Change in internal energy. And this factor delta U only we need to calculate. So children, we can write directly delta U from in terms of Q and W by the relation. That means delta U equals to Q minus W. Okay, so let's substitute the value now. Q, the amount of heat that is given with sign is minus 80 calorie. Minus this work done as is positive, and the value we have already calculated is 0.0022 calorie. So both have same sign, so I just add the quantities. It will be minus 80 point, okay, 0.0022 calorie. So you can see the increase in internal energy is given as minus 80.0022 calorie. And this internal energy value which we have calculated is with what sign? Minus sign. That means it is negative. So internal energy can also be positive, it can be negative, but this internal energy which we have calculated is what? Negative. Okay, so from here I can say that on freezing the internal energy of water decreases. Negative sign shows that the internal energy of water what? Decreases. And this decrease is more than the heat that is given to the water. And the heat given to the water is how much? 80 calorie. And the increase in internal energy is 80.0022 calorie. So I write down finally that during freezing, okay, the internal energy, the energy we have calculated, that is called internal energy of what? Water. This is for water, decreases. Because of this minus sign, we understand that the internal energy what? Decreases. And this decrease, you can even see the value, this decrease is more than what? More than the heat given up by the what? Water. Because heat also given out by the water, and that heat given out by the water is 80 calorie with minus sign, but the increase in internal energy is even more than that, that is 80.0022 calorie. So this is the solution of problem number what? 3. Now we solve next problem, that is problem number what? 4. Alright children, now we move to the next problem. As I said, that is problem number 4. And problem number 4 says that when a gas as a system undergoes a change adiabatically. Now see, you know there are a number of processes in which the first law of thermodynamics is based. Now one of the process you have learned is called adiabatic process. And you know, in case of adiabatic process, there is no exchange of heat between the system and the what? Surrounding. Now suppose a gas undergoes a change adiabatically from an equilibrium state A to another equilibrium state B, then 22.3 joule of work is done on the gas. This is the work which is done on the what? Gas. Now I do this problem first case, divided in two cases. First case for what? Adiabatic process, for adiabatic process. So this is for adiabatic process. So in first case for adiabatic process, okay, how much amount of heat work which is done on the gas, and that work done is W, okay, and this work done is how much? 22.3 joule. But children, you know that when work is done on the gas or work is done on the system, that work done is taken as what? Negative. So this work done I am taking with which sign? Minus sign, is because work is done on the gas, because your gas outed as a system. Okay, but under the process called adiabatic process, Q is always 0, means there is no heat exchange between the system and the surrounding. So Q is what? 0. That means for adiabatic change from state A to state B, Q is simply what? 0. So under this condition, we can calculate one of the energy called internal energy. And to calculate the internal energy, the change in internal energy, I use what? First law of thermodynamics. So I write down from what? First law of thermodynamics. First law of thermodynamics. Now from first law of thermodynamics, I can write that delta U, I write directly delta U equals to Q minus W. So children, we can write directly the expression of internal energy in terms of Q and W by the relation, that is delta U equals to Q minus W. So let me substitute the value. So Q is 0 minus W, but this W value is what? Negative. So I write down minus, now W with sign, I write down minus 22.3 joule, which means your internal energy of the gas is minus into minus what? Plus, that is 22.3 joule. So from here I can say that the internal energy of the gas increases. Means when work is done on the when the work is done on the system, when the work is done on the gas, the internal energy what? Increases. So there is an increase in what energy? Internal energy. There is an increase in what? what energy? Internal energy, because this internal energy will be positive when there is an increase in what? Internal energy. Now the second part of this question says that if the gas is taken from same state, so same gas means same system taken from same state A to another state, same state another state B through a process in which 9.35 calorie of heat is absorbed by the gas. I mean, this time the heat is absorbed by the gas, and when heat is absorbed by the gas, remember children, that heat is always taken as positive. Absorption of heat by the system is always positive. So how much work is done by the gas? Means we have to calculate the work done by the gas. And children, remember this, work done should also be positive. Because when work is done by the system or by the gas, that work done should always be positive. But children, when we take the same system under the change of same two state, so any process which takes place, the change in internal energy remain what? Same. Because that gas is made up of same molecules, same number of molecules, okay, so that the change in internal energy remains what? Same. So in the first part, when the process was adiabatic process, the change in internal energy we calculated as 22.3 joule. The same change in internal energy even takes place by taking the same gas which undergoes change from same state A to state what? B. So children, as the explanation which I have done, that the change in internal energy for any process which is adapted to the change from the same two states, that is from state A to state B, will always remain what? Same. That means the change in internal energy that we have already calculated in the first process, that is called adiabatic process, is how much? 22.3 joule. The same change in internal energy is adopted for the next process, that is for the second process. Now for second process, okay, your change in internal energy also what? Same. That means delta U is also equals to 22.3 joule. Okay, but in this process, how much amount of heat that is absorbed by the gas? That is Q equals to how much? 9.35 calorie of heat is absorbed by the gas. And when a system like a gas absorb the heat, then that heat is taken as what? Positive. So I am putting what sign? Plus sign. But I convert this calorie into joule, because we are measuring internal energy in what? Joule. So I write this calorie also in joule. And there is a relation, 1 calorie equals to 4.18 joule. So it will be 9.35 calorie means 9.35 into 4.18 joule. So just multiply by 4.18. So if you multiply with the help of calculator, okay, we get approximately 39.1 joule. So 39.91 joule with what sign? Plus sign. This is the heat that is absorbed by the what? Gas. That means plus 39.1 joule. Okay. So under this process, the work is even done by the gas. And that work done by the gas we need to calculate. So I write on that work done is W. Then W be the what? Work done by the what? Gas. But children, remember this, when work is done by the system or the gas, that work done is always positive. And we calculate this work done also as positive. But to calculate the work done, again I use from what law? First law of thermodynamics. First law of what? Thermodynamics. And children, you know first law of thermodynamics relation is Q equals to delta U plus W. So that W I make a subject as Q minus delta U. Now let me substitute the value. Q with sign plus 39.1 minus delta U is how much? 22.3. Okay, so when you do the subtraction, you get how much? It is 16.8 and the unit is joule. But this work done, which is also coming as positive. Yes, it should be positive because the work is done by the gas. And when work is done by the system like a gas, that work done is always positive. And this is the answer of question number, problem number 4.